Okay, we're going to go over transforming quadratics. Now, before we did go over some transforming quadratics. We talked about this formula here, which is our vertex form. Okay, and vertex form, the good thing about it is it really helps us find our vertex. Okay, and we'll talk about how it does that. And we talked about certain types of vertex forms. We talked about when we had y was equal to x minus h squared, where we only had one variable. We talked about y is equal to x squared plus k. And we talked about y equals ax squared. Okay. We talked about how those individually transform our quadratic. Okay. They change the graph. What we're going to do today is we're going to actually put all three together. Now, we technically knew how to solve this before by just plugging in random values of x. We would previously make a table, an xy chart, and plug in values of x, maybe -2, -1, 0, 1, 2, and then solve for values of y and plot those points to make some parabola. What we're going to do now is we're going to learn on how to use each of these three types of transformations to look at an equation in full and transform it or graph it without having to do anything else. Now, when we say transform the quadratic, we're always talking about from one specific point, being y equals x squared, right? Where is the vertex of this parabola? 0, 0, good. Okay. From there, how do I draw the parabola? If I were to go over 1, how much should I go up?
1.
Yeah. Then I go back to the vertex. Let's say I went to the left 1, how much should I go up? Good. What if I go over to the right 3, how much should I go up? 9. We square that number. If I go to the left 2? 4. Good. We always square when we go up. And because this is symmetrical, we can kind of just fill in the rest. So when we talk about transformation, we're talking about from this parabola here. Okay? This one hasn't been transformed at all. In fact, I'm going to write this parabola here in this vertex form and show you the actual values of a, h, and k. So what that one looks like is y equals x. Okay? Our a value is 1, our h value is 0, and our k value is 0. And that's what we mean by our vertex form, that the h and the k will tell us exactly where our vertex is. The h value will give you the x of the vertex, okay? And the the k value will give you the y of the vertex. So, let's take a look at this. Our k value in this one, I wrote in k, I meant to write in the number 0 here. Our k value here is 0. So our y for the vertex is 0. Our x value is -0. So technically, remember I told you that we want to look at the h value, the operation in front as the opposite. Okay. So had this been, since it's -0, it would be technically what? What would be the opposite of a negative?
Positive.
Positive, good. But because it's 0, there really is no negative or positive version of that. So we just write in the value of 0. Okay? And we'll get into more detail when we have different numbers for h, about how to find that vertex. So we know the vertex of this is 0 and 0, which makes perfect sense because that is exactly where the vertex is. And remember we talked about a compressing and stretching parabolas. We'd go over, we would square whatever we go over by, and then multiply by our a value. Well, our a value is 1. So if I go over 1, 1 squared is 1, and I times 1, does that change the number at all? If I go over 3, how many do I go up? 9. What's 9 times 1? Still 9. Didn't change anything, okay? So our a value in this original one is still technically the number 1, okay? So that's what our original parabola looks like, written out in like the full vertex form. But when you simplify this, okay, let's simplify it right now. Y equals, well, what's x minus 0? X, okay, so we still have the 1. We have x squared. And plus 0, does that 0 change anything? No. Do I need to write the multiplied by 1? And when I bring this squared in the brackets, it just becomes y equals x squared. So that's exactly how we go from the vertex form to our original one. We're just expanding and simplifying. So let's actually take into account if h, k, and a were different numbers. H does what?
Going like going from side to side.
So our H, like you said, Ethan said, it's horizontal translations. K is what type of translation? Up and down. And A deals with flipping. Okay. So whether it faces up or down. And then stretching and compressing. So we'll say SC. Okay, for stretches and compressors. So A has quite a few jobs. So we're going to write in a question here. Call this example 1. Y equals negative 3x plus 2 squared plus 6. Okay. First thing we want to do is identify everything in our vertex form for their variables. Okay. So we need to know what the A variable is. What is the A variable in this one? Negative 3. What is our H variable here? Yeah, positive 2. Okay. And what is our K variable? Positive 6. Good. So we have these. H and K are going to tell us exactly where the vertex is. Okay? So I want you guys to try to deduce where the vertex would be. What would the vertex of this be? 6? Yep. Not quite 2.
Negative 2.
Negative 2. Remember we talked about H being the opposite sign. Our K or X value is going to be negative 2. And remember, the reason being is because we always go from this parabola here. Well, because H is not intuitive, if it says positive 2, we go to the left 2, which is exactly the number negative 2. So negative 2 and 6 gives us our vertex. So let's plot that. Negative 2 and 6. Here's our vertex, okay? Once we have our vertex, we can go about creating the rest of the parabola. Our A value is negative 3, so that's important. Let's talk about that. We always start at the vertex. We go over 1. And then where do we move and how far? If I go over 1 from the vertex, how do I draw the next point on the parabola? I go over 1 and I square it. So how high should I go up? 1. That's right. But our A value is negative 3. So instead of going up 1, I have to multiply 1 times negative 3. What do I get? Negative 3. So we go over 1, down 1, 2, because it's negative, 3 spots. This is the hardest part about drawing these parabolas. Okay? Let's do the exact same thing on the other side. If I were to go to the negative, or to the left 1, what's negative 1 squared? Positive 1. But what's positive 1 times negative 3? Negative 3, right? So because this is symmetrical, we kind of already know that the next point is going to be down 3. Then we go back to that vertex again. Let's go over 2 spots. What's 2 squared? 4 times negative 3 being A. Negative 12. So I go down 12 from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we know on the other side, we'd be going down 12. The next one won't fit on the graph, but this is all we'd have to do is connect these dots. All right? And this is what our parabola would look like. Now, we know it faces down. We know we're correct because our A value here was a negative. And this is thinner than the one before because our absolute value is greater than 1.